So good morning, 100% here. 19 says 102 database management system, second year and fourth semester. So unit number 2, transaction and concurrency control. So what is concurrency control? It is a database management system. Concept is used to address conflict with simultaneous accessing or alternating data that can occur with a multi-user system. So yeah, bowl is available on the table. So a bunch of fruits are available. We have two-person. And I'm starting time. Which person is first to come? First basis to take up bunch of fruits. If suppose if any one of you take, there is no problem. If two-person can be take a same time to take a bunch of fruits, you can conflict or concurrency control can be occur. So if any one is possible, of data can be stored in your database management system. This is one of the image for concurrency control. So by A and B is available. By A and B same time to access of your data on your table. If anyone can take a data from particular query, suppose by P by B can occur same time, both can be created concurrency of database management system. So we can solve some basic conditions are available. So one of the example, road traffic. So we have 4 lanes. One lane, the immediate solution, immediate process. That means ambulances come. So four lanes are can be jump the traffic. One can release, can go out of one process. The same time, you can concurrency control can be occur. So we can solve this process in your concurrency control of your database management system. So why do we need concurrency control? The DBMS allow both of actions are concurrently. It would be impossible to recognize which data is updated. If DBMS choose one changes, other one become meaningful. Both solutions make a database inconsistency or useful. Useless process. So, or if the transactions are executed serially, the sequentially with no overlap in a time. The no transaction concurrency exists. However, the concurrent transaction with interleaving operations are allowed in uncontrolled manner. Sometimes this unexpected, undesirable outcome can be present in your database management server. So this problem can be raised. So easily recover of data in your system. So we have 3 things. One is last update problem and dirty read problem. So last updated problem, a second transaction write the second value of data item, top first value returned by first concurrent transaction, and which need by their precedence to write first value, the transaction that have read wrong value with the incorrect results. The third read problem, the transaction read a value written by transaction has been later about. The value disappear from the database upon about they should have been read by any transaction. This is called dirty read. The reading transaction inconsistent data. Third one, incurrent summary problem. While transaction takes summary over the value, all inconsistent repeated the data item. The data item second transaction update inconsistent. The data item can be result summary does not reflect current results. For example, I'm working. Sorry, I am insert ATM card in machine. Complete the process. Okay, complete the process. There is no problem. So my data can be updated. Same bank account. Suppose due to some failure, what happened? This is a incorrect summary problem. Incorrect means I have already the money taken from ATM machine rupees 10,000. So due to some failure, cannot updated. Other same account value can be updated once again, means this is called incorrect summary of your problem. So once refresh, you can update your system is update your data from your same account detail. This is a process of database management system. So precedence of order between two transactions, if one executed before another. So rather some random results depending on timing of update and whether certain update results have been included the summary or not. So this is last updated T1 read x equal to x minus 5, write x committed. Okay. Suppose read transition to read x plus 5. So here once executed x. So executed value can be updated, means x for example 10 minus 5, you can update it 5. Is it okay? So same process, there is no intermediate value. So you can, for example, 5 is accepted here, 5 plus 5, 10. But is a last updated. In a value, the update, you have complete your solution. And before one check a value and after updated your process. This is last updated. Read x equal to x minus 5. Read x equal to 5. So the date updated last your data, your process. So only this updated succeed. After completion, only is updated succeed. So this uncommitted updated, this is called dirty read. So T1 and T2 read x minus 5. This is going to complete the process. If suppose the process can be modified, the value is rolled back. The transaction 2 read x plus 5, write x and committed. This read value of x which should be not have seen. So example, once I write process write x, after concurrently your process x can be initiated. And for example, you have 10 minus 5, you can 5 is answer. You can assign here 10 plus 5, 5. Sometimes can be updated value. Same, you can read your undirty value can be updated in your database. So inconsistency of data. So T1, T2, read x equal to x minus 5, write x and read x, read y. Sum equal to x plus y, the read value y equal to y plus 5, right? Y, the summing of data while it is being updated. This is called inconsistency data with process. So concurrency control, we have using two mechanisms. One is three mechanisms: optimistic, pessimistic, and semi-optimistic. Your concurrency control mechanism. So first, optimistic, delay the checking whether the transaction meet the isolation or integrity rule. For example, seriability and recoverability is available or not until it is in. Without blocking of its read and write operation, and be optimistic about the rule being met and abort the transaction to prevent the violation. If the desired rules are not be violated upon it committed, and abroad a transaction is immediately restored and re-execute, which incur are obviously overhead versus of executing it to be in only once. If not too many transactions are about, then being optimistic is usually a good strategy. And pessimistic and semi-optimistic means the block of transaction. If it is many cause violation of rule, until the possibility is violation disappear. Blocking operation is typically involved with the performance of reduction. And semi-optimistic block operation is some transaction if they may cause while delaying rules becoming of checking if transaction in as done it optimistics. So we have a method. One is locking, two-phase locking, and graph checking, timestamp ordering, commitment ordering in your sector. So concurrency control algorithm, we have two processor can be most important. One is pessimistic, optimistic. Pessimistic locking protocol, timestamp ordering protocol, hybrid mode, and optimistic locking protocol, timestamp ordering protocol. So this is one of the case. So write up and see transaction ID. Once insert the execute value, read and committed, and execute in insert visible. And once process access, easily complete a transaction. If not visible, your transaction can be not done in your sectors. So this is my evaluation list of concurrency mechanism. Please tell me three top process. One is optimistic, pessimistic, semi-optimistic. Thank you.